Hello everyone, in this video we are trying to understand the parameters used in Landtrendr. Previously we just learned to prepare this graph. Getting this graph is not easy. We just click in this option called the pixel time series options, and as soon as we selected the indices and click this submit pixel, we get this chart. But to really understand how this chart is working, or to really refine the resulting chart, we need to understand the parameters used in this Landtrendr. And if we check the site of this tool, we get to know that there are 9 arguments. So we have 8 control parameters that just adjust how the segmentation in spectral and temporal basis is done, and the last is the annual image collection. That's the 9th one. We just passed the image collection, and the 8 parameters are the main parameters that we can control, and these parameters define how the graph will be prepared. So let's try to understand a few of them here. The first one is the maximum segments, and this is the value, takes the value as integer, and it says that the maximum number of segments to be fitted on the time series. So to basically define this, the first one is the maximum segments, and it is basically the number of segments or the number of linear pieces that the algorithm needs to feed to time series. So it is basically used to control the complexity of the model. So if the higher number is given, it will capture more detail, but also contains the noise. And if we give it as the low number, it might miss the subtle change. So suggested value by the Landtrendr is as 7 or 8 or 7, something like that. The second one is the spike threshold, and it is the type as float type, and the default value is 0.9, and it says that the threshold for dampening the spikes 1.0 means no dampening. And the spike threshold is to identify or to particularly ignore any spikes in the time series. So what is a spike? A spike is just the sudden change, or that might not be the part of the long-term trend. So it is interpretable in the term itself. So the spike is sudden changes, which might not be the part of the longer term trend. So this value is used to reduce the impact of any anomalies. So the spikes may be the result from any noise. So that might not contain, or that might not represent any significant change. So the default value here is 0.9, and if we pass 1.0, it means there will be no filtering, and the lower values will mean more severe filtering. So we can change this as well. So we have to select the value that just does its job. And the third one is the vertex count overshoot, and this is the integer type, and the default is provided as 3. And it says the initial model can overshoot the maximum segments plus 1 vertices by this amount. Later it will be pruned down to maximum segments plus 1. And to understand the maximum segments, so here we can see the default is 3. I was talking about the vertex count overshoot. So the default value is 3. And it means the number of vertices or change points. So vertices itself means the point where the change is occurring, the drastic change. And this is the case where the algorithm needs more segments to adequately model the time space. So for instance, here is the figure. So this one is the vertex at the beginning, the end, and somewhere here where the value changes is the vertex, the exact turnover of the spectral values or spectral frequency. And the next one is the percent 1 year recovery. So this is Boolean. That means it will set true or false. The default is false, and it says that the prevent segments that represent 1 year recoveries. And if this is true, it will consider any recovery period, even shorter than 1 year. So basically, when we use this is we either want to include short-term recovery or not. So if it is true, it will consider any recovery period or the present values. And if this is false, then we won't include any short-term recovery. And let's see, the next one is the recovery threshold, and it is float type. The default is 0.25. And it says if a segment has a recovery rate faster than 1 by recovery threshold in years, then the segment is disallowed. And what it means is it is used to determine whether the recovery has occurred or not. So it kind of relates to the changes in spectral value observed for that segment. So it is to consider as part of recovery. So when we pass 1, so this is TONF. For instance, if we pass 0.25, the segments that fully recover in faster than 4 years are not permitted. So anything that is being recovering in 4 years are not included. Similarly, the next one is the p-value threshold. This is again float type, and here it says the default at 0.1. So it says if the p-value of the fitted model exceeds this threshold, then the current model is discarded, and another one is fitted using the Landtrendr marketed optimizer. So the p-value is basically the significance level for statistical tests in the algorithm. So it basically determines whether the changes detected are significant or not. So if we pass the value as 0.05, for instance, if we write here 0.05, what it means is that there's 5% chance that the observed changes are due to some kind of random variations. So basically, it is to do some kind of statistical test. And the next one is the best model proportion. This is again float type. The value is 1.25, and it takes the model with most vertices that has p-value that is at most this proportion away from the model with lowest p-value. So it is used to select the proportion of a best fitting model to retain during the model selection. So if we pass, for instance, 0.75, so here is default at 0.75. So the 75% of models are considered for final model. So it is just to select the proportion of the models for the final model. And the last one is minimum observation needed. It is integer type, and the default value is 6, and it says minimum observations needed to perform output fitting. So this is this relates to the number of observations that are required for this algorithm to consider a segment or the change point. And it is required to ensure the changes that the changes are based on the sufficient amount of data, and we don't want to reduce the changes just based on the limited data. So, so the higher value means there will be robust changes, and that's it. It just needs to be just like the maximum segments, selecting the optimum value to consider the change point. Well, I believe we will further learn, and we need to change this value each time and see what changes we get in the chart. So we have to do this ourselves. And the last one is the image collection. So this is the collection from which we extract trends. And we are given the option to define the year ranges and define the weight ranges as well. So again, to simply conclude, we need to be more familiar with these segmentation parameters. The more we are aware of them, the more we can get meaningful interpretation of the time series. So thank you for watching.